All right, so the new unit we're starting is about these things called polynomials. We've been working with polynomials already. All the different types of equations that we've been dealing with are technically polynomials, but in this unit, we're going to zero in on exactly what these things are and what we do with them. So like I said, this first part is just going to be a lot of like terms, definitions, giving you the lay of the land, exactly what we're talking about, and then we're going to do some stuff with it. Okay. So like I said, if you want to try to write this stuff down, go for it, but don't freak out if you don't write down every single thing. All right. So polynomial, what it is? It's a monomial. What does mono mean? One. So a monomial is just one thing. That's what a monomial is, one piece. What does poly mean? It means multiple. Like you guys talk about like polytheistic and monotheistic religions? Yeah. So like a polynomial is multiple things. That's all it is. Okay. So this is a polynomial because it's multiple things. Each one of these things is called a term. Okay. So this polynomial has 4 terms. There's a couple other things we got to talk about. The first number that you see in front of everything, you guys probably, I mean, we've talked about this already, but that's the leading coefficient. We've used that language before. That should be kind of familiar. So the first number you see, that's the leading coefficient. The biggest power, biggest exponent, we call that the degree. The degree of the polynomial, that's the biggest exponent. And then if there's a term at the end without a variable, we call that the constant term, because it doesn't have a variable and it doesn't change. Okay, so again, just lay of the land, different pieces of polynomial. Other thing, standard form of a polynomial is something that we're going to talk about a lot. In order to write a polynomial in standard form, here's all you need. You need the biggest exponent first, and then you decrease from there. So if you got exponents, you put the biggest one out in front, and then you go down from there. So like this example, this is in standard form because it's 3, 2, 1, no more variables. Yeah. You would combine those terms. Yeah. So like if I have this, that's not in standard form. Why not? Yeah, you want the big exponent to be in front. So to put it in standard form, it would need to be like this. So I don't like this, but I do like that. That's in standard form. Does that make a little bit of sense? Okay. All right, I'm going to throw some other words at you. Again, don't feel like you need to write all this down. We're moving kind of fast through this stuff. We can classify polynomials by their degree. And there's some names that we give them based on their degree. So let's say it's a first degree. Remember, degree is the biggest exponent. So a first degree polynomial would be something like this. Oh my gosh. That'd be something like this. 2x plus 1. That's a first degree polynomial because the biggest exponent is 1, right? That's a linear polynomial. You guys know what linear things are, right? It's lines. Talk about that a lot. Going up from there, second degree polynomial. That's maybe something like this. The biggest exponent you see is 2. What does that look like? It's a quadratic. Oh my gosh. We've already talked about a lot of this stuff. A third degree polynomial might look like this. 5x cubed plus 2x minus 7. I'm just making it up. Biggest exponent you see is 3. You know what the word is for that? Cubic. It's a cubic polynomial. Okay. Fourth degree. I think you all kind of know what this is going to look like, 6x to the fourth. Does it matter what happens after that? No, this right here, I just left it like that. That's a fourth degree polynomial. Doesn't matter how many pieces it has, it's degree 4. Anybody think they know what the fancy word for that is? Fancy math word? It's a quartic. I don't know how you would have known that. A quartic polynomial, okay? All right, at this point, whoever was like defining these back in the day, I don't know the history of this, but it's kind of fun to think about. Yes? Yeah, probably. Yeah, that makes sense. It's kind of funny to think about the history of this. I don't know how these terms were coined, but whoever was making this up, whoever was coming up with these terms, they got to 4, they were like, okay, quadratic, cubic, quartic. They get to 5, and they're like, well, I'm kind of out of creative juices. So they just said, anything other than 4, like anything bigger than 4, I'm just going to call that a 5th degree or a 6th degree, and so on. I don't know. I mean, we're not really going to operate with like anything bigger than 4 very much. So maybe that's why. I don't know. But they got above 4, and they're like, you know what? We're done with this. Let's just call it the number. Yep. Well, 5th degree polynomial is just something where the biggest exponent you see is a 5. And then everything after that doesn't matter what it is. It might have each one, so it might be like this. It might look like that. Or a 6th degree might just look like this. That's a 6th degree. It doesn't matter how many terms there are. It just matters what the exponent is. Okay, is this making a little bit of sense? All right, one more thing. This is classifying based on the degree, right? That's the biggest exponent. You can also classify it based on the number of terms, which we were already kind of talking about a little bit, okay? If you have one term, that's something that looks like this, 2x, or 4. It's just one thing, right? We already talked about this a little bit. What's the prefix for 1? Mono. It's a monomial. Okay, if there's 2 things, maybe like 7x squared plus 2, that's 2 things. That's a binomial. What do you think 3 things is going to be? Trinomial. It doesn't matter what the 3 things are, as long as it's just 3 things. So it could be 792x to the 18th power plus 16.5x cubed minus 1. I don't know. Is that 3 things? Yeah, it's a trinomial. Doesn't matter what they are. And again, they get to 4, and they think, well, I don't really know what to say. So they gave up. Polynomial. So anything bigger than a trinomial is just a polynomial. So 5, 6, 7, doesn't matter. Anything bigger than 4 is just a polynomial. All right? Is this stuff making a little bit of sense? Again, if you didn't write all this stuff down, that's okay. I know I'm throwing a lot of terms at you. This is going to get posted on Google Classroom if you need to go look at it later. All right. Okay. Let's look at something else. I'm just going to plow through so we can get done. Is that okay? You guys give me a couple more minutes? All right. Here's what we need to do with the polynomials. We need to do operations with them. We need to add them. We need to subtract them. We need to multiply them. That's what we're doing. So let's do one thing at a time here. It says simplify and then classify by degree and number of terms. So let's just do one thing at a time. Simplifying a polynomial basically just means do whatever operation it's telling you to do. Okay, so what is this telling me to do? It's telling you to add. I am adding these things. Maybe you remember this from Algebra 1. Maybe you don't. I'm going to add these things. All I got to do, guys, is add like terms. That's all I got to do. I'm just combining like terms. So I'm just going to go from left to right. I got 3x cubed. So I do 3x cubed plus what? X cubed. I'm looking for like terms. So there's an x cubed here. I'm looking for the x cubed over here. All right, so what's 3x cubed plus x cubed? 4x cubed. Cool. Moving on to the next one. 2x squared plus negative 10x squared. What's that? Negative 8x squared. Moving on. Negative x plus, uh-oh. The second one is missing something. What's it missing? It's missing x. That's fine. It's okay. It's negative x plus nothing. So it's just negative x. Okay, don't let it freak you out. And then one more. What color have I guess I'll do blue. Negative 7 plus 8. 1 plus 1. Did I do every piece? Yes. Can I combine any of these? No, why not? None of them are like terms, right? I can't combine x cubed and x squared. I can't combine 1 and x squared. It's just not going to work. So all my like terms are done. So this is my final answer. Look at all these colors. So we're done. Can you even see that? Can you see that yellow? That's so bright. All right, what degree is this? Remember, degree is exponents. It is a third degree polynomial, which means it is cubic. Okay? How many terms does it have? 4, which means it is what? A polynomial. There's 1, 2, 3, 4 terms. So it's a polynomial. Cool? Does that make a little bit of sense? Okay, let's look at a different one. This one's a little bit different. What's different about it? It's subtraction instead of addition. That's the only difference. So we're going to do the same thing, except now, instead of adding, we're going to be subtracting. Okay, so one thing at a time. 8x to the 4th minus, I got to find the like term. It's just x to the 4th. What's that? Oh, I'm going to run out of colors here. Look at all these things. Man, you are just, you are in some kind of mood this week. I know, I am running out of time. Negative 3x cubed minus 5x cubed. Huh? No, I'm going to have to just give it, I'm just going to have to do an override. It's okay. What's negative 3 minus 5? What? So? I don't care. What's negative 3 minus 5? It's not negative 2. It's negative 8. You got to be careful with negatives and subtracting. If you need to put it in a calculator, just do it. 2x squared minus negative 3x squared. Think about it. 2 minus negative 3. What is it? 5. Positive 5x squared. Okay. What does this one skip? It goes from x squared to a constant. Does this one have an x? Yes. Here's how I'm going to think about it. It's 0x minus 2x. Yeah? What's 0 minus 2? Negative 2x. Got to be careful. Make sure you do each of your pieces in the right order. And watch out for the negative. Okay, we got one more. What color? I need to redo a color. I haven't done black. I'll just do black. Negative 15 minus negative 12. Negative 3. All right. I can't combine anything. I did all my pieces, so I'm done. What's the degree? Fourth degree. Fourth degree, so it is a quartic. How many terms? 1, 2, 3, 4, 5. So it's a polynomial. Wow. Cool. Okay, I bet I could get to 20 minutes. 20 minutes is the new cap. Okay, here we go. 20 minutes. What is going on here? Oh my gosh. What? All right, what is this telling you to do? Multiply. Oh my gosh, we're multiplying. It's crazy. Hey, don't let it freak you out. We're multiplying. You just got to distribute, okay? Remember when we talked about we multiply with the eyes, we had to do that double distributing stuff? Same thing here, except I have 3 pieces. So if we were double distributing before, what do you think we're doing here? Plus 1 is what? Triple. Okay? I just got to multiply each piece by each piece. All right? So don't freak out. What's x times negative x squared? Yep. What's x times 2x? What's x times 4? Okay, there's that one. Now I just do it with negative 3. Same thing. Multiply it by all the pieces. Negative 3 times negative x squared. Positive 3x squared, because this is negative 3. Be careful here. Negative 3 times 2x. And negative 3 times 4, negative 12. Am I done? No. What can you do? I can combine some stuff. X squareds and x's. Yes? I got some stuff to combine here. Did I have any other x cubes? No, so that just stays the same. What comes next? Okay, so it's 2x squared and 3x squared. So that's 5x squared. What's next? The x, and how many x's do I have? Negative 2, because 4 minus 6 is negative 2. And what's at the very end? There were no other constants, right? So negative 12 didn't change. All done. Capiche? Okay. Oh, one more. Oh my gosh. I don't know. You can change. Ooh. Wow. Learning a lot. Okay, I got one more. Oh man. Woo! 2x plus 3 cubed. What do you think you're going to do? What does cubit mean? So is it 8x cubed plus 27? I cubed everything. What if it was this? This is not, you never do that, right? We never do that. This would be 2x plus 3 times 2x plus 3. What is going on with my marker? So what I'm trying to tell you is this. Sorry. What I'm trying to tell you is this. You are not going to do this. Okay. If you do that, one-way ticket, baby. Wouldn't you like to know? Nobody's been back to tell the tale. You're not going to do that. Instead, what you're going to do is this. 2x plus 3 times 2x plus 3 times 2x plus 3. And doesn't that look like so much more fun? What? And then what? Yeah, no, we still got to multiply it out. Yeah, I bet we can get through this quick, and then I'm going to be done, okay? I'll show you. First, just look at the first two. Double distribute them like normal. 2x times 2x, that's 4x squared. 2x times 3 is 6x. Again, we're double distributing, so that's another 6x, and then 9. I can combine those, right? So that's 4x squared plus 12x plus 9. So now I got to do that times this other 2x plus 3. So I multiplied the first two things, it turned into this. Now I multiply that by 2x plus 3. And we just did one like that up here, right? So we got to do this triple distributing stuff. I'll do some colors here. 2x times 4x squared, that's 8x cubed. 2x times 12x, that's 24x squared. 2x times 9, that's 18x. And then I do the same thing with the other piece. Multiply it by everything. So that's 12x squared, 36x, and 27. Yes? You agree with me so far? All right, so now I just got to combine some stuff. I got some squareds, and I got some x's. Okay. So one more thing to write, and then we're done. 8x cubed, nothing happened with that. I guess my answer is blue, whatever. What's next? 36x squared. How come I'm not doing the x part here? Well, I am, but how come I'm not going to write, what is it going to be? 18 and 36, what is that? 54? How come I'm not putting 54x right here? Because that's not standard form, that's not the right order, right? I got to do decreasing order. Cubed, squared, single x, and then constant. Done.